Detecting what parts of an object can move and estimating how the parts move when they open or close is useful in many tasks, including perception for robotics and embodied AI. We proposed the Openable Parts Detection task, or OPD for short. In this task, the input is a single view image of an object, and we predict openable parts and their motion parameters. For each part, we predict a bounding box, segmentation mask, part category, and corresponding motion parameters, including the joint type, joint axis, and joint origin. Prior work is designed for 3D point cloud inputs and assumes the objects have a fixed kinematic chain. In other words, independent models are trained for objects with different number of parts and different motion types. In contrast, our goal is to generalize across object categories and kinematic chain structures. We design a network architecture that works at the part level and detects arbitrary number of parts and their motion parameters. Our approach is designed to generalize over different categories and instances with varying number of parts. The input to our network is a single image. Our network, OPD-RCNN, extends the instance segmentation network mask-RCNN. We extract the feature maps and use region proposal network to extract the potential anchors. Then, for the part detection, we use the same mechanism as mask RCNN. For the motion prediction, we have two versions. For our simple model, OPD-RCNN-C, we directly predict the motion parameters in the camera coordinates in the box head. For OPD-RCNN-O, we predict the motion parameters in the canonical object coordinate and add additional branch to predict the object pose in a single object setting. To develop our approach, we create two datasets of objects annotated with openable parts and motion parameters. One dataset is based on existing synthetic 3D models of articulated objects. Another dataset is based on 3D mesh reconstructions of articulated objects we collected from real indoor environments. We annotate all objects in these datasets with ground truth parts and motion parameters to create a large dataset of single view images for training and evaluating our approach and baselines. Using these datasets, we systematically evaluate our approach against baselines and prior work, with metrics capturing both detection and motion parameter estimation performance. We find that our approach significantly outperforms alternatives, especially for accurate motion parameter estimation across diverse object categories. We conduct a systematic evaluation comparing the two variants of our methods against baselines using metrics that measure openable part detection and motion prediction for different input modalities. We see that our method significantly outperforms the baseline. For more details, please refer to our paper. In summary, we have the following contributions in this paper. We propose the OPD task for predicting openable parts and their motion parameters. We contribute two datasets of objects with annotated parts and motions. We design a simple image-based structure-agnostic method. See our paper, code, and data at the following links or scan our QR code. Thank you for listening.